Hello again. This is our simulation analysis using our AnyLogic model for the Antico Cafe Greco ACG case study. In the previous clip, I elaborated the model. We're just going to explore the different scenarios now, hopefully line them up with what we found with the queuing calculator. So I'm going to run the base case, and to find the set the parameters up, you go to simulation main and you can adjust them here. So in the base case, we have pooled orders coming in at the rate of 105 per hour. The baristas, there are 3 of them. They each serve at the rate of 55 per hour. That's a mean of 65.45 seconds per coffee per order, with a standard deviation of 10 seconds. So we'll run that. And I'm going to run it twice. So I previously calculated how many minutes we should simulate. I'm going to just revisit that calculation with you. So we can only do 50,000 instances or customers, flow entities in this model because it's the free version. So 50,000 divided by 105 was something like 476 hours. Multiply that by 60 is 28,000 minutes. So I'm going to run this thing. Here it is. It's busy running. It's just got to, let's see, 29 minutes. And I ran it in the previous clip to 50,000. Should be running it to 25,000. You can run it to 28,000, but I'm just gonna, keep it to 25,000 and then run this. You can see I'm getting an estimate here of 1.3 minutes. Okay, now I do want to go back and just do a second run just to confirm that this is a reasonable estimate. So we just go down here, change the seed to any other number. 22 would be fine. And just rerun it. And it's just going to give you sort of like another look, another time evolution of the system for 25,000 days in our case, 25,000 minutes rather. And just to see if what variation you're getting. Now, typically, you should do a few runs here for each scenario to see if this one varies. I'm going to now hurry it up all the way through the 50,000. Well, less than 50,000, 43,000. Customers are now getting 131. Very similar to the 1.3 that I got, 1.30 on the previous seed. You can maybe do a third or a fourth to build your comfort. The standard deviation here is probably going to be pretty low. So I'm happy that I've got the base case analyzed. Now, let's go and have a look at changing this to go back to simulation main here. Just have to scroll back to where my parameters are. Let's have a look at, so we can analyze 4 customers as we did initially. You can run that. And again, you should run multiple seeds just to confirm performance. I'm going to run this one to 25,000 also. No, I'm not going to do those extra runs, but this one comes in lower. All right, I've got extra help. I am having to pay the extra salary. It is coming in with a better customer experience. How much better is a good question. But that is, analyzing it with 4. Now I'm going to have a look at 2. And I'm going to run this one for you. We know that 1 doesn't work, right? 1 is too few. This is now 2 baristas. The base case, but moving it to 2 baristas. And again, I just click on the ellipsis, make this 25,000 and run it. Okay, click on this fast forward. I think in the queuing, we came back with something like 6 minutes. Now, this estimate is 5.85 minutes. I'll run it again, this one again for you. Notice how my utilization is at 95%. According to this, this is an average across the hours. of 94.8. I think this is sort of a short run average. Maybe it's just rounding it, the 94.8 up. I'm not quite sure what the difference between these two numbers are, but they're pretty close. Okay, so we'll do one more iteration of this one with a different seed, just to see what other numbers are. I want to make this 7. Let's run it. Let's go to 25,000 again. So we had 5, I think 85. Okay, so these 43,000 customers is experienced a time in system of 7.12. You'll have to do probably 5 runs here to get an average, but it is seemingly, there was some variation around the 6 minutes that we found with the queuing result. The queuing result would be exact. If you did a number of runs with the simulation model, you're going to see that they will converge to that queuing result, but consistent, right? Now, that is changing the number of baristas. Let's go back to the base case and look at the automation example. So I'm going to go back to 3 baristas, no standard deviation. There, no standard deviation here. So switching out the Venus Arduinos that are semi-automatic for automatic coffee bars. See how that flies performance-wise. Expecting to see a result that is lower than the base case because there's no variance on the server side now. Run this. So it comes in at 131, essentially the same as the base case, right? And you could try another couple seeds to see if that is, it should be slightly less on average than the base case, but not by much. So that's the automation piece. Now let's see what happens if I remove the training, keep the original equipment, the base case with the original equipment, but I bring in noobs, untrained noobs or baristas with basic training only. So they are have much higher variance. Now, I just want to say that, the standard deviation, I think you can see what the problem is with my normal distribution. We talked about this before, but I just want to discuss it again. Your mean here is 65.45 seconds and your standard deviation is 100. So you're going to easily get numbers that are negative, but I am using a truncated normal. So this distribution is, this analysis is conservative because I'm not allowing service times to go negative. So just bear that in mind. So we're not going to get a complete match with the results from the queuing analysis, which is exact. Right, so I will analyze this for the usual 25,000 again. And I can just zap this. And you can see I'm really blowing up. 719 minutes. You'll have to change. I want to just change the seed again. It's very hard to get good estimates of performance with high variance scenarios. So I'm just going to change this to 10. And I'm also getting a conservative estimate here. So I'll run this again. See if the 700 was how reliable that was. I know it's high because of the approximation, but am I going to get that again is a question. Okay, 730. So there's a fairly significant mismatch here between the time in system, expected time in the system for the simulation results and the queuing. And you can see I'm at 99% this time. I should have observed what it was the previous time. But this truncated normal is a major approximation, and it's giving us, inflated wait times relative to the queuing. The queuing is in fact what it is, so it's like 6 minutes average there. Okay, so that's a scenario that's hard to get alignment between the queuing model and the simulation model. And the last one that I need to analyze for you is what happens if we take the pooling away? So let's just go and have a look at that. So now, remember, each barista is dedicated to an area of the cafe, seeing arrivals at the rate of 35. And each of them will see 35 per hour. That's the 105 per hour total. The service time is 10. It's the original trained baristas, and there's only one barista now. So let's just see what happens with this. Okay, so this is removing the pooling of the orders. Now, you could actually simulate this for like 75,000 minutes, but I'm going to just do the same old 25,000. The reason you can simulate more is because arrivals are now only 35, so you could do 50,000 divided by 35, so about 1,500 hours roughly. But I'm just going to do it for this, just keep everything consistent. You'll see I only have about 15,000 customers, and the waiting time is 2.09 minutes. So it did go up from the base case. Whether this is something that you want to do, remove the pooling, is for you to discuss. Well, I think we got good alignment between the queuing model and the simulation model for every scenario except where we remove the training. And the reason we got poor results from the simulation model, a mismatch between the queuing and the simulation results for that scenario, was because I'm using that truncated normal approximation for the service time distribution because I don't want to get the negative numbers, and because it is a high variance scenario. Anytime variance is high, you're going to see the average results are all over the park, and you're going to have to do more replications of your runs to get a good estimate. But the rest of the scenarios lined up, I think, pretty nicely. Hope you enjoyed this. Good luck with your deliberations.